Yes, sir, that's my book.
Okay, Umar. Now, Asha Bashi, first of all, one question was left in the last class, right? That was this. There were two parallel lines. Okay, and there was a okay. Let's say this was PQRS, PQRS, and ABCD. Remember, we were doing this calculation last class. This was left A,
Yes, sir.
B, C, D. We have to prove that AB is parallel to CD. Given is, which I was what I was guessing, it has to be that way only. So given is PQ is parallel to RS. We need to prove to prove to prove AB is parallel to CD. How do we prove that? See, first of all, construct a line, construct BD, sorry, not BE perpendicular to PQ and CF perpendicular to RS. Okay, so BE, draw a line BE perpendicular to P this, so 90. This is E, and draw from here a perpendicular CF, that is also 90 degree. Okay, now but again we have to apply the same thing. Angle of incidence is equal to angle of reflection. But name this as angle 1. This is angle 2. Okay, this is angle 3. This is angle 4. So proof angle 1 is equal to angle 2. Reason being law of reflection. Okay, law of reflection. You know law of reflection, right? Angle of incidence
Yes,
is
sir.
equal to angle of reflection.
Yes, sir.
Angle of incidence. Okay, angle of incidence is equal to angle of reflection. Then angle 2 and similarly, we can write angle 3 is equal to angle 4, right?
Yes, sir.
So angle 3 is equal to angle 4. Same reason. Now, can I write angle 2 is equal to angle 3 because of alternate interior angles? Because 90 degree, 90 degree, so they are perpendicular, right?
Yes, sir.
So remember I taught you how to prove B is parallel to parallel to CF in the last class. You have to apply that same. B is parallel to CF. So therefore, angle 2 is equal to angle 3. Angle 2 is equal to angle 3. Alternate interior angles. Okay. Now, you can write. See. See now. Can I write angle 1 plus angle 2 as angle
Yes, sir.
2 plus angle 2, right?
Yes, sir.
Basically, I can write that as twice of angle 2, right, Umar? Are you getting my point?
Yes, sir.
And can I write angle 3 plus angle 4 as angle 4, angle 3 plus angle 3? So this means that twice of angle 3. Okay, so now what I'm going to do is multiply by 2 on both sides. So multiply by 2 on both sides, multiply by 2 on both sides. So twice of angle 2 is equal to twice of angle 3. Twice of angle 2 is equal to twice of angle 3. Now twice of angle 2 I can write as angle 1 plus angle 2 and this I can write as angle 3 plus angle 4. Right, Umar? Got it?
Yes, sir.
Now, angle 1 plus angle 2 is nothing but ABC, angle ABC. Angle ABC. This is angle ABC. And angle 3 plus angle 4 is angle BCD. Angle BCD. So that is equal to angle BCD. Now, but when they are equal, so they act like alternate interior angles. Interior angles. Therefore, AB is parallel to CD. Is this clear, Umar?
Yes, sir.
Please write this down.
Okay, sir. Then, sir.
Okay, Umar, now note this down.
Then, sir.
Okay, Umar. Okay. Now starting with triangles. Umar, what is a triangle? Very simple. Triangle is a three-sided figure. Triangle, three-sided polygon. Okay. So, well, first of all, let's understand that what is congruency of triangles. Okay. First, first of all, let's understand that what exactly is congruency of triangles or figure TUS and C, PQR. So, congruency of triangles. Triangles. But see, Umar, see, congruent triangles. What are congruent triangles? See, suppose I have two triangles, this and this. Okay, and I say that they are congruent. So when I say now that they are congruent, so this congruency means that suppose I pick up this one and I place it on it, so they will exactly overlap. Okay, exactly overlap. That are congruent triangles. Okay, those are congruent triangles. Basically, they are congruent figures. So, like, if I talk about this triangle, let's name it ABC. Let's name this PQR. So, let's say PQ. So, in congruent triangles, na, every side and every angle is equal. That is only then it will be a congruent triangle, right? Only then it will be a congruent triangle. So, if I say AB, so now in congruent triangles, Umar, sides are equal. So AB is equal to PQ. AB is equal to PQ. BC is equal to QR, and AC is equal to PR. Now, if you write CA, then you have to write RP. This is very important. If you write CA, you have to write RP. So AC is equal to PR. Now, if I talk about the angles, but there are three angles: this, and this, and this. So I'll say angle A is equal to angle P. Angle B is equal to Q, and C is equal to R. Is this clear first of all?
Yes, sir.
Okay. See. So now, Umar, therefore we can write that triangle ABC is congruent to triangle PQR. Okay, triangle ABC is congruent to triangle PQR, but this sign equal to and a S and a later हुआ S, they are, that is the congruence sign. So we call it triangle ABC is congruent to triangle PQR. Is this clear, Umar? What is congruency of triangles?
Yes, sir.
Okay. Umar, I'll give you an example. Tell me whether these triangles are congruent or not. And you don't have to tell the congruency by just looking at them. You have to tell them by the measures of their sides.
Okay, sir.
Yes, Umar. Tell me, bache, are these triangles congruent?
Yes, sir.
Yes, they are. So can you tell me which triangle is congruent to which one?
Uh, Triangle ABC is congruent to triangle PRQ.
PRQ. No. See. ABC is not congruent to PRQ. ABC is congruent to triangle QRP, because see ABC mein you are traveling the path 5 and 4. So QRP mein you should travel the path 5 and 4. Got it? So now QRP. Got it? So here triangle ABC is congruent to triangle QRP. But see, this is very important, that writing the correct order. Is this clear?
No, sir.
That's fine. See, Umar, first focus on this only. But I said ABC is congruent to triangle PQR, right?
Yes, sir.
Achha, Umar, first note this down. Tell you the next part later. First write this much down.
Okay, sir. Then, sir.
Okay, Umar. See. So now, if I say that triangle ABC, I have two triangles, PQR. If I say that they are congruent, triangle ABC is congruent to triangle PQR. So, बच्चे, in this case, na, AB would be equal to PQ. AB would be equal to PQ. Instead of equal to sign, we put this. BC would be equal to QR. BC would be equal to QR, and AC would be equal to PR. AC would be equal to PR. First of all, you learn that about the sides. Okay, and corresponding angles. Like A, like first here is A, so first here is B, so A would be equal to P. Are you getting my point? Similarly, B would be equal to Q, and C would be equal to R. But see, the reason is, इसके according ही we make the triangle. इसके according ही we make the triangle. ABC is triangle congruent to triangle PQR. This means that I can only keep like uh, just put up something. See, Umar, wait.
Okay, sir.
Umar, can you see these two papers in my hand?
Yes, sir.
Umar, I said that they are congruent. Okay, but they are only congruent. See, there are actually some doctors' lab reports. See, they are identical papers. Just one is colored printout, one is black and white. Okay. Now, I hope you can see this clearly.
Yes, sir.
Okay. Now, I would say that they are congruent only when I keep this on this exactly like this. Okay. Now they have properly overlapped. Even the writing, this written Sabharwal. Okay. Yeah. This written one. Okay. Even this part, bache, this also has overlap. But so I would say that this triangle, this rectangle is congruent to this. But let's say I name this. I name this A, B, C, D, and this as PQRS. Are you getting my point? I named it like this. Now, Umar, if I write in any order that ABCD is congruent to RPQS, now what will happen? What would this mean? That ABCD is this one is congruent to this. But see, now they are not congruent, right? Like if I keep them like this, are they congruent now?
No, sir.
No, right? So for congruent, they have to be properly overlapped. So that is why it is very important that, let's say this point is A. See, let's say that this point is A and this point is P. So A should be coming over on P. So this is how you write the congruency. Is this clear first of all?
Yes, sir.
Are you getting my point? That A, B, C, D. So similarly, P, Q, R, S. They should correspond. Okay. So it was like that. So now, Umar, if I say, so first of all, is this concept clear?
Yes, sir.
Okay. Now, A, B, C, and P, Q, R. So A and P should correspond. B and Q should correspond. C and R should correspond. So I cannot write, Umar, I cannot write ABC, triangle ABC. Let's say if I name the sides, if I mark the side, this is 4, this is 4, this is 5, this is 6. So this should also be 4, 5, 6. Now, Umar, there is no way I can write that triangle ABC is congruent to triangle, let's say QRP or QRP. No, I cannot do that. The reason being, this means now that AB is corresponding to QR. So now you are saying AB and QR would overlap. No, but on while overlapping, they would not properly overlap. Got it? What I'm trying to say?
Yes, sir.
Okay. So
Okay,
now,
sir.
in this case, tell me, triangle ABC is congruent to which one?
No, sir. The upper triangles are not equal, but the lower triangles are.
See, Umar, they are congruent. ABC and BU are at ABC and both the triangles are congruent. You just have to mark it. Like basically one is
No, sir.
tilted.
They are not congruent.
But see, they are. I am telling you they are because the sides are equal. Now think about it for a minute and see that ABC is corresponding to which one? Whether it is QRP, PQR, PRQ, QPR, what it is. Try it down. Take a minute.
Okay, sir.
Okay.
Sir.
Yes, Umar.
Sir, those triangles are not congruent. No, not congruent.
See, Umar, they are congruent because if I let's say tilt it, if I tilt PQR, see, I can say the triangle ABC is congruent to triangle. Now see, AB, AB is 5 centimeters. So here what side is 5 centimeter? QR. So QR and BC is 4 centimeters. So RP is 4 centimeter here. So basically AB is equal to QR, BC is equal to PR or RP, okay, and CA is equal to PQ. CA is equal to PQ because they are, see, this is 5 centimeter, this is 4 centimeter, this is 3 centimeter, right, Umar? Right?
Yes, sir.
Okay. Now let's say they are equal. So now triangle ABC. See, AB is corresponding to QR. So AB is corresponding to QR. BC is corresponding to RP. So I'm going to write RP. So now see, it will complete everything. How to check it from here? See, this should correspond here. AB is corresponding to QR, right? See, AB and QR are equal, that is 5 centimeters, right, Umar?
Yes, sir.
BC is equal to RP. So BC and RP are equal and they are next to each other also. So BC and RP. So first how to check this? And lastly, AC is equal to QP as AC is equal to QP as 6 centimeters. Got it? Got it, Umar?
Yes, sir.
Okay. So now from here, we can also write down that A is congruent to P, not P, sorry, Q. So like now, if I have to overlap them, now I have to put ABC and QRP on it, not PQR, not SA. Okay, like this is ABC and like this is PQR. Okay, so ABC and PQR I don't have to overlap. I have to overlap ABC and QRP. Now QRP is like this, so they overlap. Is this clear now?
Yes, sir.
Umar, imagine this PQR triangle. We are rotating. We are rotating like this. Okay, it is being rotated like this. So if I rotate it, it will come to a point. If I rotate this very carefully, it will come to a point where like ABC is like this, and this triangle also looks like this, where this is 5. So this also is 5. This is 4, this also is 4, this is 6, this also is 6. So now when you rotate this line, you'll find this is Q, this is R, this is P. Exactly. So now can you see them congruent directly? So is the whole point of congruency clear?
Yes, sir.
Okay, great. Umar, note this down, this second part, this one. Also write till it is tilted. If you want to make, you can make an animation of tilted in your notebook. But this should be totally clear. Most important thing it is. Okay.
Yes, sir.
Are you done over writing this? Umar, are you done writing this?
Yes, sir.
Are you done writing this?
Almost, sir. Yes, sir.
Okay, Umar. So, to tell you the criteria. Achha, Umar, for, one more thing. Like, let's say we have proved this triangle congruent, right? We have proved this congruent, right?
Yes, sir.
So I can like with these sides only we have proved this congruent. But in congruency there are 6 things. Angles are also congruent. So I can write A is is equal to P. Sorry, not P. A is equal to Q. B is equal to R, and C is equal to P. And basically the reason for this we write is CPCT. What do we write? CPCT, but the full form is congruent parts of congruent triangles. Congruent parts of congruency parts of congruent triangles. But if we have proved, see, a triangle is only congruent when all the 6 elements are equal, like all the 3 sides are equal, Umar, and all the 3 angles
Yes,
are
sir.
also equal. But when the 3 sides are equal, now we directly prove. You learn that in criteria of congruency, that when we have 3 sides, we can prove them congruent. Once we have proved them congruent, then we can say that A, so like other parts also are congruent. That is why we write CPCT in the bracket, which means congruency parts of congruent triangles. Means these parts are also congruent because the triangle is also congruent. Got it?
Yes, sir.
Yes.
Yes, sir.
Okay, Umar. Umar, just write this down, CPCT, and then let's say you can. We'll be done with today's class. We'll be continuing this in the next class. Okay.
Yes, sir.
Okay.